calculating density given a sample. So in this example problem, it says a sample of aluminum, Al, is shown below. If its mass is 116.64 milligrams, what is its density in grams per centimeters cubed? So we have the sample of Al here, and it's measured in millimeters. So what we can do, because we know that our answer is going to be in centimeters cubed, is to convert all of these into centimeters so that when we multiply them, we get centimeters cubed. You can do this afterwards, but it's basically the same thing, because all I'm going to do is divide each side by 10 to get centimeters. So it's actually going to be 0.6 centimeters, 0.60 centimeters. This is going to be 0.18 centimeters. This is going to be 0.40 centimeters. And notice I'm keeping the same amount of significant digits when I do this conversion. So you can do this at the front end, or you can just divide the answer by 10 3 times if you multiply the millimeters together. So what I'm going to do now is multiply the centimeters to get centimeters cubed, so I can get the volume of this object. So I'm going to multiply 0.6 times 0.18 times 0.4, and I'm going to get the volume as 0.0432, or because of the centimeters cubed, or because of the significant digits, I'm going to get 0.043 centimeters cubed. So I have the volume now. Great. And we know that density equals mass over volume. So we have the volume in the correct unit that we need it. So what we're going to do now is try to get the correct unit for the grams. We have milligrams, so we know that 1 gram actually equals 1,000 milligrams. So what we have to do with this answer right here is divide it by 1,000. So I'm going to put 116.64 times 1 gram, because that's what we want, and we have milligrams here, and then we're going to put 1,000 milligrams, and the milligrams are going to cancel out. So what I have to do is multiply across and times it by 1, and then, like I said, divide by 1,000. So we're going to move the decimal place 3 places to the left, because when you divide by 1,000, that's what you're going to do. So 0.11664 grams is what we're going to get for the mass of this object. So now that we have mass and volume, we can calculate the density of this sample. So we're going to do 0.11664 grams divided by 0.043 centimeters cubed. And notice that it's going to give us grams over centimeters cubed, which is exactly what we want the density to be in. So let's do this. 0.11664 divided by 0.043 is going to give us an answer of 2.71255, and then a couple of other numbers, grams per centimeters cubed. So that's our density, but we know that we have only 2 significant digits, because that's how we started off with the volume. So we're going to round this, and we're going to get the answer as 2.7 grams per centimeters cubed for the density of aluminum, or this aluminum sample. So 2.7 grams per centimeter cubed is the answer to this problem.